All right, this next page is going to be a continuation of our transformations, and we're going to again focus on the absolute value function. Now, we've already written down the absolute value function once. We're going to write it down again. It is f of x equals absolute value of x. Now, I do want to write a question up here, and the question is, what is the vertex form for an absolute value function? It's the same packet. It is before the homework page. So what is the vertex form of an absolute value function? Now, before we get to the vertex form, we're going to do these little warm-up exercises that we've already done. We've done these. We know how to do these. Just real quick, describe how the following functions compare to the parent function. So what does this minus 5 do? Right 5. What does this absolute value of x plus 9 do? Up 9, because the 9 is outside the absolute value. What does this negative do? Okay, what does the 3 do here? Stretch by 3. And then the minus 2? Down 2. Alright. E, what does the 1/4 do? Shrink by 1/4. And the plus 6 does what? Left 6. Alright, and then F, what does the negative do? What does the plus 7 do? And down 2. Alright, very good. So that's what we just talked about that. We did some problems. We didn't get those on film, but we did do them. Alright. Now, what is vertex form of an absolute value function? The vertex form of an absolute value function is a format that we write where we include all the symbols for all the transformations all at once. So instead of just saying absolute value of x, we're going to have all the little pieces there. So this is what it's going to look like. F of x equals negative a absolute value x minus h, close your absolute value, plus k. Now, the negative tells us to do a what? Reflect. The a value tells us to do what? Stretch or shrink. The h tells us what? Left or right. And the k tells us what? Good. Now, the great thing about vertex form is it gives you the vertex. Imagine that. Vertex forms gives you the vertex. Now, another thing about this type of format is that you can do vertex form for any function. We're focusing on absolute value right here. But we could also do quadratic. Let me show you. You don't have to write this, but I'm going to write it. F of x equals negative a parentheses x minus h squared plus k. This is quadratic form. This is the quadratic vertex form.
What are we doing now?
Alright, you're not doing it. Later on we will be. Alright, and then you could do cubic if you wanted to. You could do square root. The same rules for these transformations will work on all of them. That's what's beautiful about it. You can transform or graph any function by using your vertex form of whatever the function is. Now, specifically we're talking about absolute value. The vertex is going to be h comma k. Now, the h value is going to be the opposite of what you see inside the absolute value. So if it says x plus 2, what would the h be? Negative 2. If it says x minus 2, it would be positive 2 for the h. It's always the opposite for the h. And the reason that is because our formula involves a negative. Alright, now, the fact that we're taking the opposite of the x is going to come into play later on over and over and over again. We're going to be dealing with opposite of x. It's going to happen over and over again. Alright, now, We're also going to say that the A value is the slope on the right side of our graph, and negative A is the slope on the left side.
That makes sense.
Now, it really doesn't matter which one you do. All right, you could do, well, it doesn't matter, and I'll show you why in a minute. I could put negative A right here and positive A over here. Since it's absolute value, it's going to work out either way. Now, we're going to learn how to graph these things by using the vertex, and we're going to use the A value as the slope. So, first of all, let's find the vertex of this thing. All right, let's say what the transformations are. You say right 2, down 4. So that's what's happening. So normally, for the parent absolute value function, the vertex is at 0, 0, correct?
Yeah.
So if I were to go right 2 and down 4, that takes me to my new vertex. So graph that point. Now, I don't need to do that. I don't need to be told what the transformations are in order to do that. I can just look straight at the vertex. The vertex is the opposite of negative 2, which is positive 2, and then negative 4. Look, 2, negative 4.
That was like so easy.
So easy. Now, the next thing we do is we use A as slope. Okay, now the A value is only going to give us part of our graph. It's only going to give us one side of the graph, right? To get the other side, we're just going to reflect.
Is the A value the X?
The A value is like your slope.
1/1?
Alright, so what is my slope in this problem?
1/1.
My A value, I mean. It is 1. So 1/1 will be the slope. So from this point, do up 1, right 1. Now, that's only half of the graph. That rhymes. That's only half of our graph. So how would we get the other half?
Up 1, left 1.
There you go. Up 1, left 1. Now I want you to think of it for a minute. If we use A, and A was 1 to start with, it says right here that the other side of the graph is negative A. Well, that would be up 1, left 1. So you can think of it in terms of the opposite slopes, or you could just reflect it visually. You could say, okay, well look, technically there's like this dotted line through here, and that separates the two halves. These are mirror images. So when I get this point, all I need to do is reflect it over that line to get another point. Alright, let's do number 2. Won't y'all do number 2?
Oh, no.
Alright, first of all, you got to find the vertex. So what is the vertex of this problem?
1.
Negative 5. And what is the K value? 0, because there's nothing out there.
Are we going to stretch it?
We are going to stretch it. I'll show you that in a minute. Alright, so negative 5, 0 is my point, my vertex. Go left 5 on the x-axis, and there it is. Now, we're going to use the A value as a slope. So A value is equal to 3. So how would I do that?
Up 3.
Up 3.
Right 1.
Right 1. Very good. And that's only one half of my graph. How would I get the other half? Reflect it. Or up 3, left 1. And we're done. Now you tell me, is this quicker or is making a table quicker? This is a lot quicker. Super easy. Alright, let's flip it. Okay, on number 3. Let's do the vertex. Okay, so Taylor, what is the vertex for this one? Alright, someone who has got it. Alright, DeAndre. Negative 2 is the K value, but what is the X value, H value? Negative 1. So go left 1, down 2. That's your vertex. Okay, so we're going to use the A value as the slope. So Katie, what is our slope? 2. So up 2, right 1.
see Raiders to report from jail building at this time.
Have fun.
All right, so we've got Vertex of -1, -2. We've got half of our graph. The other half is reflected. So just reflect it up to left 1, correct?
Yes.
All right, there you go. Okay, I'm going to stop the video and let you do a few on your own.